Hello there, I have here an example problem regarding confidence intervals. This in specific is going to be focusing on what kind of sample size, rather how large of a sample size will we be needing in order to fulfill some sort of specification regarding margin of error and standard deviation. So let's get started. We would like to estimate the true mean annual electricity usage by all Canadian homes. Suppose that annual electricity usage follows a normal distribution with standard deviation 1,472 kilowatt hours. The first question we have here is what sample size is required to estimate the true mean annual electricity usage to within 400 kilowatt hours with 90% confidence. The formula we are going to be using here is the sample size is going to be equal to the standard deviation multiply z-score. The z-score is actually the confidence level divided by the margin of error, then squared. So what kind of values do we have here? Well, we know the standard deviation is given in the question as being 1,472. So we have our standard deviation 1,472. The margin of error is given in this question over down here as being within 400 kilowatt hours. So we want that kind of margin of error is going to be 400. Now our z value is given as being 90%, but we need to convert that into the z-score, the standardized z value. In this specific video, I won't be going over how to get the confidence levels z-score because it's a bit different than getting normal z-scores from certain values when you're given a mean and some sort of standard deviation. I will be using a standard normal probability table right here. In the value it takes in this form is already a confidence level. I don't need to do any modifications to the normal z-score. Rather, I'm just going to be using the value I get out of this. If you want to know how to get the specific confidence level or the z-score, I will probably have a video on it soon, or you could just search for other videos on YouTube. Now then, we're looking for a confidence level of 90%. Look for 90% right here. The associated critical value, or just the z-score of the confidence level, is given as being 1.645. So that's what we're going to be using. So our z value for 90% confidence is going to be 1.645. Now it's just a matter of plugging in all the data to get our sample size. So here's the data plugged in. Now if you actually did this calculation, we would get an exact answer of about 36.6. But whenever you're calculating the sample size for a confidence level or a confidence interval, you always round up. Even if you got an answer of like 36.02, you would always round up to 37. So our answer then is actually 37, which is the answer we get over here, so we know we were right. And this is how we would solve question 1. Now let's move on to question 2. What sample size is required to estimate the true mean annual electricity usage to within 100 kilowatt hours with 90% confidence? So the only difference from this question to the first is that we're dealing with a different margin of error. Instead of 400, we have 100. It decreased by a factor of 4, we could say. Our z value is still the same, 1.645, because we're still looking for a 90% confidence level, but our margin of error is different. So let me change this over here from 400 to about 100. Okay, so it's just a matter of plugging in the data again, using this formula right there. This is the formula with all the stuff plugged in. Now let's just do the calculation again. This actually gives me a value of approximately 586.3. But since we always round up when we're dealing with finding out sample sizes, we're going to be getting 587 instead. And that is the answer over here, so that's how you would solve that. So let's move on to the next question now. For a given confidence level, how many times larger a sample size is required when we divide the desired margin of error by 4? To answer this question, let's just say we had a margin of error of, let's say we were using question A, which is 400. Well, we put 400 down. This is the margin of error. Now it's asking what kind of sample size will we need if we reduce this margin of error by 4. So we're reducing it by 4. It's going to be becoming 100. And we can get that by doing 400 multiply 1/4. Now, whenever we reduce a margin of error by some factor, in this case it's going to be 4, the factor you're going to be multiplying the sample size by to get the new required sample size is just going to be the factor that you reduced it by squared. So in this case, we are reducing the margin of error by a factor of 4. So we're going to be doing 4 squared So 4 squared, which gives us 16. Now this 16 is going to actually be the factor we're going to multiply the sample size by, which was given as being 37, to get the new sample size. And if you did 16 multiply what we got in the first question as being 37, you would get an answer around 592. And that is a pretty good approximation to the actual answer, which was 587. Now, to answer this question, however, it's asking how many times larger a sample size is required. How many times larger? Well, the factor we got was 16. So that's going to be the answer. We're just going to have to multiply 16 by the sample size originally to get the new sample size. And that's how we would answer that kind of question. So let's move on to the next one. Using only the result from question A, what sample size would be required to estimate the true mean annual electricity usage to within 800 kilowatt hours with 90% confidence? So notice here in question A, we had a margin of error of around 400 kilowatt hours. But only using the result from question A, we need to find out this new data right here. The new sample size with a different margin of error. The only difference between question D, the one we're trying to answer, and question A, is that the margin of error has been doubled. So it's been increased by a factor of 2. All that means is the required sample size would have to be 2 squared, but to be dividing that by the sample size we got in the first question, we just have to work backwards. So it's going to be 37 divided by the factor that we got doubled by, or the factor that it changed by, which is going to be 2 squared. Instead of multiplying it by that factor like we did in the other question, we're going to be dividing it by that factor because we're working backwards, as I said. So this gives us an answer of about 9.25, but we always round up, so we're going to be getting an answer or a sample size of 10. And that is what we got here, so that's how you would solve this question. Let's move on to the next one then. What sample size is required to estimate the true mean annual electricity usage to within 400 kilowatt hours with 98% confidence? Okay, so we have our margin of error as being 400, not 100, so let's replace that. And our z-score, our confidence level, is different as well, so we have to change it. The new confidence level is 98%. Now we have to go back to our table and look for 98%. So we have a z-score associated as being 2.326. So that's going to be the new value we're going to be using. 2.326. Now it's just a matter of plugging in the data again. We have 1472 multiply 2.326 divided by the margin of error as being 400 and squaring it all. This will give us our answer as being an exact answer of 73.26, but since we always round up, it's going to become 74. The reason we round up, by the way, is because we can't have half of a sample. Like say we want to take a random sample of 10 people, we can't have 9.5 people, right? It's just that basic logic. Anyways, this is the answer to question E. Now, time for the last question. Comparing the results from question A and question E, what happens to the required sample size when we increase the confidence level? Well, in question A, we got a sample size of 37. We had a confidence level of 90%. And in question E, we had a confidence level of 98%, but the required sample size was 74. Therefore, the sample size increased. Whenever we want to be more confident about something, the required sample size in order to be that confident has to increase. This is assuming you still want to keep, mind you, the same margin of error. So whenever margin of error is fixed, whenever you still want to keep the same sort of interval between your mean, the sample size would have to increase if you want a larger confidence level. To summarize, whenever you want a larger confidence level and you can't change the margin of error, this 400 is what I'm talking about here, you always need a larger sample size. That is the conclusion to this video. If you have any questions, feel free to ask in the comment section below. I will answer your questions, and I hope you're having a nice day.